All right, hello, welcome to geometry. We're going to do lesson 10.3 notes. And the goal of this is to apply the Pythagorean theorem and its converse to solve problems. So the main formula that we'll be using is the Pythagorean equation, which is a squared plus b squared equals c squared. Occasionally, we will see Pythagorean triples, which will allow us to not have to use the Pythagorean theorem, and the two most common are 3, 4, 5 and 5, 12, 13. You also will occasionally see 45, 45, 90 triangles. And the sides have a ratio of 1 to 1 to root 2. And you'll also see 30, 60, 90 triangles, which have a ratio of 1, root 3 to 2. Okay. So let's start with the first one. What is the longest stick that can fit in a cube with a side length of 4 inches? Go ahead and draw a rough sketch of a cube. Okay, so 4, 4, 4. Every side length is 4. I also will like to draw the back edges. I can see a little bit better. Okay. So the longest stick is going to go from corner to corner. And it would be this, if I were to draw a dashed line, be this distance right here. So we're going to use the Pythagorean theorem to solve these problems. Now the Pythagorean theorem only works with right triangles, but thankfully this is a cube. And so this angle right here is a right angle. Then if I draw the dashed line down here, I'm going to have a right triangle right there. So I can kind of redraw that triangle over here. Nice. And this length here is 4. And this length here, let's just call this, we'll use a different, just call this length here x. And the length down below, I'll call d. Okay, so I'll label this side d and this side x. So to solve for x, first of all, is this a special right triangle, like a 30, 60, 90 triangle? Well, we don't know, right? We don't have any angles other than a 90-degree angle. And so we don't know. But we do, however, if you look, it's different. Let's see if I can get a different color here. To find D, though, look at this. If you make a triangle right here, and there's a right angle right there. And so you have a right, doesn't really look like isosceles triangle. I'll make it a little bit more to scale here. You have a right isosceles triangle, where this is 4 and 4, and that is a 45, 45, 90 triangle. That's going to make this 4 times the square root of 2. And so D is equal to 4 root 2. Okay. So now we can solve for x. Now is x is this orange triangle a special right triangle? Well, it could be, and it would be if maybe it was 4 root 3, but it's 4 root 2, and so that's not the ratio that we see over here. We see 1 root 3 to 2. So it's not a isosceles right triangle. It's not a 30, 60, 90 triangle. So in order to solve this, the only way to do it is with the Pythagorean theorem. So 4 root 2 squared plus 4 squared, because again, the side opposite the 90-degree angle is the hypotenuse, so that's c, equals x squared. Now, when we're squaring 4 and the root 2, we need to make sure we square both of these numbers. And that's going to be 16, and then root 2 squared is 2. And so that's going to be 32 plus 16, that's 48. And then we'll do the square root of 48 equals x. Now, usually when you're doing these problems, like in lesson 2 or lesson 1, you'd leave your answer as root 48. But in this case, these numbers refer to a distance. And so you're not going to go to someone and say, well, the length of this is root 48. You would actually give them a number. So go ahead and put this in our calculator, and we'll get that x is approximately equal to 6.93 inches. And that would be our answer. So to review, the key with this is to draw a picture, and then you're going to identify an orange triangle and a green triangle. The green triangle helps you get D. And once you have D, you can use the orange triangle to get the longest distance in the cube, which is basically where the longest stick could potentially fit. Okay. Next problem. So in this one, the question is, what is the longest stick that will fit inside a 24-inch by 30-inch by 18-inch box? So again, the first step when doing this is to draw a picture. But in this case, I've drawn the picture for you. And so this time it's not a cube, though. Hold on. There we go. Okay. It's not a cube. And so we first need to find what? Well, we need to find D first, because that's going to be, if we can find D, where this is 24 and this is 30. And once we have D, that will allow us to find X, because the other triangle that we have right here is such where we have X, D, and 18. Okay. So first of all, you could ask yourself, well, is it a special right triangle? Is it a 3, 4, 5, 5, 12, 13? No, it ends up not being. So we're going to have to do the Pythagorean theorem. So 24 squared plus 30 squared equals D squared. And if you put 24 squared plus 30 squared into your calculator, you will get 1,476 equals D squared. That means the square root of that number is equal to D. Okay. So now that we have D, what we can do is use that to solve for X. So we have 18 squared plus D squared equals X squared. Well, we know that D is root 1476, so we also know that D squared equals 1476. So I can plug that over here, and then I will get 18 squared plus 1476. That's going to equal X squared. Okay. So you're plugging that in. And let's see here. What is 18 squared? 18 squared ends up being 324. So I can actually just write that. 324 plus 1476 equals X squared. So that's 1800 equals X squared. And so that means the square root of that equals X. And again, since this does refer to a distance, the longest stick in the box, we're not going to say that the length of it is root 1800. Instead, we'll give the answer. So X, if we go over here, we're a little bit out of room here. I don't like that. Let's put it down here. 42.4 inches is approximately equal to x. There's your answer. So to review, the key with this, with the rectangular prism, is to see and visualize the two right triangles inside it. And in order to use the Pythagorean theorem, there has to be a right triangle. Once we do that, we can see that if we have two sides of a triangle, a good way to find the third side is the Pythagorean theorem. Now, if you have a special right triangle, or you have like we did in the first one, well, then use that. But if you don't see it or you're not sure, just use the Pythagorean theorem and it'll work every time as long as you have two sides. Like, for example, in the first one here, we could have just done, in the green triangle, we could have said 4 squared plus 4 squared equals, I believe that this side, the 4 root 2, was called D, right? This is, I actually want to label that. This is D. And so you could say 4 squared plus 4 squared equals D squared, and then solve, you get exactly the same answer. So it's really up to you. Okay. Final example here has to do with at a local community college, the area between the buildings is 120 by 120 square shaped grassy area. To accommodate the way students walk across the area, the school is going to put in a sidewalk on a diagonal going across the square. To the nearest meter, how long will the sidewalk be? So again, you have a square. So draw a picture. Let's visualize this. So a square, we know, has all right angles. And we know that all the sides are congruent to each other. And the lengths then are going to be 120 by 120. And we want to know how long will the diagonal be across it. Let's call that x. So what you could do is you could do the Pythagorean theorem, right? 120 squared plus 120 squared equals x squared, and you could solve. That would work. Or you could notice, wait a minute, what kind of triangle, I can, if I have a highlighter here, doesn't want to select. Okay, we'll try a different color here. What kind of triangle is this triangle right here? A blue triangle. That's a 30, that's a 30, that's a isosceles right triangle, right? So if I draw this triangle right here, it's an isosceles right triangle where each length is 120. That is isosceles, this means it's a 45, 90 right triangle, which is going to make x equal to 120 root 2. Oh, okay. So literally, we're done. We found x. But we're going to want our answer, though, in terms, you're not going to say the distance is 120 root 2. You want an actual estimated answer. So we'll have that d, or x, equals 120 root 2, or x is approximately equal to 169.71. But it does ask it to the nearest meter, right? And so that means that it's going to be about 170 meters. There we go. And that is your answer. That concludes the notes from 11.3. There's also, I did hand out some notes on radical review, and I'll go over that in a separate video. But in terms of the 10.3 content, this is going to be it. So again, in summary, this has to do with how to apply the Pythagorean theorem, a squared plus b squared equals c squared. But if you notice there's a 3, 4, 5, or a 5, 12, 13, or a special right triangle, you can use that as a shortcut to do it, right? And so, like, for example, On this problem, you could have just seen it's a 45, 45, 90, or use the Pythagorean theorem to solve it. And same with right here, right? And so you don't, if you can see a special right triangle, that's going to be enough work to show. Okay. All right, that concludes it. Thank you very much.